In this video, we'll talk about MongoDB. You probably have heard the term NoSQL databases. It's a term that describes a class of data storage and access solutions that do not follow relational database principles. The emphasis of these solutions are super large datasets and how to manage and access those datasets in a scalable, efficient, and flexible manner. There is some debate about exactly what NoSQL means. Originally, it meant that these data solutions did not use SQL, but people soon realized having a standardized query language is actually quite useful, and some of these solutions actually started to support SQL. Now the general consensus is that the term NoSQL is not really a good term. A better one would be not relational, because these are basically databases but are different from the relational ones. Unlike relational database systems, which are all kind of similar, NoSQL databases come in several flavors. Some of them started as caching solutions, so they store key-value pairs. Later, some of those key-value stores evolved into so-called document database, like documents like this one. You can see that a so-called document is basically a bunch of key-value pairs glued together. Another way to look at it is it's basically JSON. Or in other words, these document databases allow us to store JSON-like objects. There are a couple of other types of NoSQL databases. One is called column family stores. The defining characteristic is that they store data by column rather than by row, like in relational databases. The main representative in this category is Google's Big Table, but not many others take this approach. Another category is graph databases, which specialize in storing and analyzing graphs. These are useful if you have lots of social networking data, which naturally forms graphs with nodes and connections and so on. You can see the popularity of different database systems on the website dbengines.com. So here's the list of rankings, and the top 3 or 4 are still relational ones, but MongoDB is also pretty popular at number 5, and quite a bit more popular than the next NoSQL one, Elasticsearch. And this is the trend graph, and MongoDB, I think, is here. Okay, so this one. So as you can see, it's getting more and more popular over the years, or over the last few years. What's this one? Oh, Postgres. Ah, nice. Anyway, so as you can see, MongoDB is the most popular NoSQL database systems these days by a fairly large margin. I think probably because it's more like a general purpose database systems rather than a specialty system like some of the other NoSQL databases. In any case, it's the most popular, and it's also quite representative of the non-relational approach to data storage and access. So we'll talk about MongoDB today. As I mentioned, it is a document database, and it is also the M in the so-called min stack or MERN stack, which some of you probably have heard of. M is MongoDB, E is Express Framework, A is Angular, N is Node.js, and in the case of MERN, instead of Angular, it's React. So in this class, we are actually going to cover the MERN stack. We're going to cover MongoDB, Express, React, and of course Node.js. So you can download and install MongoDB Community Edition on your own computer if you want. But if you don't, you can use the MongoDB on CS3. The version on CS3 is the latest version, 4.4.1, and just like the MySQL database on CS3, each account has a database, and the database name is the same as your server account name. For example, my server account name is CS5220STU31, so that's the database name. Notice that there's also something called an authentication database. So in MySQL or in most other relational database systems, all the user authentication information is stored in one place. But in MongoDB, it's designed as a distributed database systems. So even the authentication information is distributed in the sense that you can specify which database that information is stored. So in our setup, that authentication information is stored in the same database owned by the account. So both the database and authentication database is the same one, and the name is the same as the server user account. And you also need a username and password to access your database, and the username password and again are the same as the ones for the server account, which you'll receive by email at the beginning of the semester. So you don't need to install the server, but you do need a client. There's a GUI client called MongoDB Compass. This is kind of their official GUI client, the equivalent of MySQL Workbench for MySQL database systems. You can download it and then install it. So from this link, you can, where is the download link? Okay, so download link is here. And if you use Windows, I would recommend that you download the installer, the MSI version, instead of the zip version. But in any case, after you install it, it should look something like this. There are 35 plugins, so it takes a little time to load all of them. Okay, so this is what it looks like when you first start it up, and you can create a connection by specifying a connection string. A connection string is kind of a weird looking thing, so what you want to do is click on this link that says filling connection fields individually, which shows a more normal connection form. And the host name is going to be cs3.casted.la.edu. And the port number, very importantly, the default is 27017, but on CS3 is 4042. That's because the default port is blocked by the campus firewall, so we have to use a different port. Very importantly, remember it's not the default port. It's 4042. And then we do have authentication. So in the drop-down list, select username password and enter your username password. And here you also need to specify the authentication database. As I mentioned earlier, it's the same database as the account database. So same thing here, and then click connect. It says authentication failed. Why authentication failed? That's because I specified the run authentication database, I think. Okay, so now I'm connected, and I already have one database for this account, and that's pretty much it. Okay, so now we select this database. What next? Well, the first thing we need to understand is the overall structure of the database server and the databases. So this is kind of the big picture view of my MongoDB server, and similar to relational database servers, each server software manage a bunch of databases, and databases is where actual data is resides. And inside each database, in relational databases, you would have tables. But in MongoDB, instead of tables, you would have something called collections. So collection is the equivalent of table. And inside collections, inside each collection, you will have documents. And those documents would be the equivalent of rows or records in a relational table. So that's kind of the analogy. There is, however, a big difference is that in relational databases, before you even create a table, you have to specify the schema of the table, what column it has, the type for each column, and so on. For MongoDB, you don't need to do that. There's no, well, you do need some kind of schema when you design your data, but the collection itself does not enforce any schema. In other words, you can basically put anything in any collection, as we'll see in a moment. So even though structurally it seems like a table, but it's quite different from a table. So knowing that, let's come back here and create a connection. The name of the connection doesn't really matter, so I'll just call it, let's call it test. Yeah, we'll call it test, why not? So now I have one collection in my database, and currently the collection has no data. There's a place where you can import data and so on, but we'll just create data manually. Remember, collections are where we store our documents, and so here we can insert a document, and you can put something that looks like a JSON object directly here, or we can do it field by field. So each document must have a ID field. It's an underscore ID, and by default, if you let the system to automatically generate that field, it will generate a value of object ID type. If you specify the ID yourself, it can be any type, but either way, it has to be unique, and this field will serve as the primary key of the collection. So this one automatically gives an ID, so we'll keep that. And then what happens after that is completely up to us. And as I just mentioned, collection doesn't enforce schema, so we can put basically anything in there. So we can, for example, say first name is Gang, and then we'll add another field that says last name is Doe, something like that. And then we have our first document. And we can insert another one, let's say, and this time we'll say file name is abcd.pdf, and then we'll also say something like parent ID is, let's change the type to integer, maybe. Yeah, something like that. So now we have our second document. Notice that both documents are in the same collection test, and you could basically put anything in there. There's no schema enforced. You can think of the first one as like a user object or user document, and the second one as a file object or file documents. And MongoDB allow you to put all of them together inside the same collection if you want. In practice, you probably don't want to do this because if you do this, your application will have a very hard time to locate where the users are and where the files are. But as a system, at the database level, MongoDB doesn't care. So in addition to collections and documents, there's also the data types. So the data types, as we can see, when you try to add a field or edit a field, it will give you a drop-down list of all the possible data types. Those data types are so-called BISON types. So MongoDB uses binary JSON as its data types, called BISON. If you check out the linked document, it will give you some. It will tell you the difference between binary JSON and regular JSON. But by and large, binary JSON is the binary form of JSON, and it makes parsing data a lot faster and store data more efficiently, because JSON is a text format intended for both human and machine to read. Binary JSON or BISON is for machine only. That being said, they are similar in the sense that they cover the basic JavaScript types, number, string, and date. The difference is that BISON has some variations of these types. For example, in JavaScript, we don't really care whether a number is an integer or a double. But if you want to store those data efficiently on disk and access them efficiently on disk, then you'll probably want to distinguish integers, doubles, and non-integers, and so on. So that's why BISON has some variations of those numbers and strings, so that you can fine-tune performance based on the actual data you have. BISON also has some additional data types. In particular, it has a binary data type that allows you to store things like a byte array. And it also has an object ID data type used for automatically generated object IDs. Now, if you think about all this, they are not that different from relational database systems. What makes MongoDB or document databases fundamentally different from relational ones is because they support object and array types. In other words, in addition to having fields of simple types like this, we could, for example, add, okay, so let's do it here. Let's add another field, and this field is going to be object field. And this object field will have a name called address, and inside it will have, what do we have for address? We'll have street, which is 1, 2, 3 Main Street, and then we'll have zip code, city, and let's say LA, and something like that. You get the idea. So you can have a field which is an object itself, and similarly, you can have a field that is an array. For example, let's make this one an array, and so let's say, what do we have for array? Let's say aliases. So this person has another alias called Steve, and another alias called Jack or something. So this would be an array, or in other words, something like this. So because of the support for object and array types, it makes the whole thing quite a bit different from relational databases, whether you talk about data modeling, schema design, or whether you talk about the data access. Object and array types makes things quite a bit different. So yeah, speaking of the object type, oftentimes it's also called embedded document or a subdocument. Yeah, so that's the basics about MongoDB, databases, collections, documents, and data types, and particularly the support for object and array data types. Now that we have all the basics covered, let's see how we can really use MongoDB. Today we'll talk about three things: data modeling, and then writing queries, and then connecting Node.js applications with MongoDB using the MongoDB Node.js driver. We'll use an example that's kind of a blog database where users can write blog articles, and then other users can comment on blog articles, and each blog article can have some text, something like that. We'll see exactly what those things look like in a moment, but this is going to be the example we use. And just like using any database systems, the first thing is actually data modeling. Even though MongoDB does not require you to have a schema, in practice you'll have to have some kind of schema no matter what, because your applications need to know where how data is structured and where they are stored. You cannot just randomly, for example, store your user objects in different collections, because later on it's just impossible to find them. And even if you can find your user data, you still need to know whether they have a first name field or last name field or address fields and so on. So data modeling is still needed, even though schema is not enforced. Now, in relational data modeling, there are fairly standard procedure to follow. You have entity relationship model. You started with an ER design. There are pretty straightforward rules to convert an ER design to relational tables, and you follow through that process, and you end up with something. It's once you get used to it, it's pretty easy. Designing for document database or NoSQL database in general, it's quite a bit more. I wouldn't call it more difficult, but it's less standardized in the sense that schema design is highly application dependent. there are all kinds of different ways to store the same data, and which one is better really depends on the application, depends on how the data is used. So there are some general rule of thumbs, but much less standardized than the relational design process. With that being said, most of the time, the different design decisions come down to whether you embed document or not to embed. That most of the time it comes down to that. So let's first explain what embed or not embedding means. So let's say that we want to design the schema for our blog example, and blogs have articles, and for each article we would have an ID, we would have title, we would have publish date. Those are pretty straightforward. And then we would also have tags, since MongoDB supports arrays, chances are we would want to have tags at the array. So that's also kind of natural. Now the question is, how do we store order of an article? Order would have things like first name, last name, email, address, phone number, additional contact information, and so on. Now, we could do something like this. We could have an articles collection that has all the articles, documents, and then we could also have an orders collection, which contains all the user documents. And each user document would have a unique ID. And then in the articles, we can simply have an order ID field that contains the ID of that order. And whenever we need to get the order of an article, we simply look up in this collection. So if you think about it, this is very similar to what we would do in a relational database. In a relational database, we would have an articles table, we would have an orders table, there will be a foreign key that in the articles table references the ID of the orders table. So same idea here. So all the ER design stuff still kind of applies, in the sense that data still has relationships, and you still need to express that relationship somehow, whether you use relational database or non-relational database. So here in MongoDB, if you read the documentation, it refers to this type of design as using a reference. So this article would reference another document that contains the other information, similar in relational design. This one, however, is a very non-relational design, and this is referred to as the embedded design, where we actually embed the other information directly in the articles. Now, the question, of course, is which one is better? And the answer is, of course, it depends. Embedding is, generally speaking, more efficient for retrieving data. For example, if you want to display an article, you would retrieve this document, and if you embed the user information in this document, then you just need to do one database access. You'll get everything you need in order to display that blog article, and that's great. If you use the reference design, you would either need to do a drawing, or you need to do two database access to get both the article and the order. So it's less efficient in terms of retrieving the data. However, if you need to update the data, embedding would be bad, because, for example, if you have multiple articles written by the author John, and then the author John later decides to change his email from john@localhost to john@gmail. Now your database, instead of just changing John's email at one place, now you need to look through all the articles, find all the articles authored by John, and change the email in all those articles. So whenever you try to update, embedding would be less efficient. If you are familiar with relational data design, this argument is actually the classical argument about normalized data or denormalized data. The denormalized data would be like embedding, which is more efficient for read, less efficient for write. And same thing here. So that basically says it's really application dependent. It depends on how you would want to use your data, and you'll make a judgment and see which trade-off you want to live with. Now, if you read the MongoDB documentation, it does give some recommendations on when to use referencing, or in other words, this type of design. So the first situation is if you need to represent complex many-to-many relationships, then you would want to use referencing. That because if you use embedding in many-to-many, you end up with just too many duplicates. You have to duplicate on both sides, and it's end up going to be not very manageable. A second situation is when you try to model large hierarchical data sets, and this one happens to be the homework project that we've been doing. If you are doing folders and files and folder structure stuff, you'll probably want to use reference design, because if you use embed, then you end up with lots of things embedded in one document, which makes it not very easy to access or search. And the last bullet point, once again, gets back to being pretty subjective. So you would want to use referencing if the drawbacks of embedding outweighs its benefit. Well, that really doesn't say much. Again, it comes down to how you are going to use your data in your application. So this is basically the thing about data modeling for MongoDB or document database in general. It's very flexible, but there are less rules or standard procedure to follow. So you have to evaluate pros and cons based on your application. There's one more approach regarding data modeling. In the documentation, it's referred to as subset. I just call it embed sum. You either reference or you embed, or you embed some of it. What that means is you kind of do a combination of the two. You embed, sometimes you can embed only part of an entity. For example, in this case, suppose you have lots of information related to an order, first name, last name, email, address, and so on. You could embed some of the information in an article, like, for example, just the full name and email, so that when you display an article, you can simply display the order and email without actually accessing the orders collection. And if you do need to access, for example, the order's phone number or address, then you can make another database access to get that information. So one way to embed is to embed part of an entity. Another example would be embed part of a collection. For example, suppose you have like an online retail application like Amazon, where you need to display product description and some reviews. And suppose typically you would display the first 10 reviews, and then if only the user click more reviews, and then you display more. In that case, you could embed the first 10 reviews together with the product information, and then use a reference to reference additional reviews in a separate review collection. So this approach is what I call embed sum. So you embed sum and then use reference for the rest. Okay, so that's enough about data modeling stuff. Come down to, again, application-specific trade-offs. Considering all that, let's say that I designed my blog database in certain way. We'll see what it looks like in a moment, but before that, let's talk a little bit about how to get some information into a database. So just like MySQL or any other relational database systems, MongoDB has a command line client called Mongo Shell. So if you are on command line and you can do something like Mongo, and since right now I'm using a non-standard port, so I have to give it a port number, and this will connect me to the MongoDB database. So this allows us to run certain queries and insert statements and scripts so that we can populate the database, query it, and so on and so forth. And if you use MongoDB Compass, there's a embedded MongoDB Shell in Compass, and it's a fairly new feature. Only has this since 1.22, and currently it's still in beta. If you don't look for it, you'll miss it. It's actually down here. If you click here, it will bring it up. So this is an embedded Mongo shell that you can use. In this case, for example, we can say use CS52 STO31. It changes to this database, and we can do db. What's the name of the collection? Oh, the name of the collection is test, and say db test find, and it will find all the documents currently in that collection, something like that. And you can do it, of course, on the command line. So there are a few basic commands that you would want to use if you use the MongoDB shell, like help to get the list of commands available, show database, switch to a database using use, and show the collections in the database. So we can do, for example, here, show collections. It will show that currently I have one collection called test, and then you can do quit. Notice that quit is actually a method, so you'll call the quit method to quit it. And in relational databases, we have a query language called SQL, and in MongoDB, there's no, well, it has its own query language if you want to call it. The language is not a language per se. It's basically JavaScript methods. So it has a number of methods that you can call, and these methods allow you to do insert, update, select, remove, and so on. So most of these methods has this form. Most of these methods are methods on the collection object, and it has this form, db dot collection name dot and then the method name. So what I just run here, db.test.find, is basically one of those methods. It starts with db and then the collection name and then the method name. So we'll see some of those in a moment. And just like in relational databases, where you can run SQL scripts, you can run Mongo shell scripts. Mongo Shell scripts is something like this. It's basically JavaScript code, and there are a few methods in the there are a few built-in methods you can use to connect to a database, to print out a value, to print out an object as JSON, to have a cursor object that you can use to iterate through the results and so on. And if you want to run Mongo Shell script, you can either using the Mongo Shell script to run it, or you can or inside the Mongo Shell you can use the load function to load it. So I want to quickly go over this Mongo Shell script, because this one will create our blog database, and later on we'll use that database to do some queries. So first of all, as I mentioned, it's basically JavaScript with some Mongo specific methods. There are a couple of things when you write Mongo Shell script. First of all, because it's JavaScript, you cannot use shell helpers commands like show dbs, because they are not valid scripts. JavaScript, you have to use basically only JavaScript syntax. And secondly, even though it's JavaScript, do not use anything fancy. Don't even use let, which is a ES6 syntax for creating a variable. I'm not sure which version of JavaScript MongoDB Shell's JavaScript interpreter supports, but I'm pretty sure it's a very old version. So don't write any fancy JavaScript syntax in there, just very plain stuff would be okay. In any case, inside this script, the first thing we would do is to connect to a database, and that takes the connect method. And then once we're in, because we have enabled security for MongoDB, so we have to do a dbauth method call to authenticate ourselves, and using my account information, ABCD and stuff. Please do not use my database, even though you know my password. And once we get in, so I did two collection job. So I did db articles.job and db users.job. So that allows me to basically clear the database, so that later on I can recreate those two things. So after I dropped those two collections, I created an index on a new users collection, and we'll talk about index in a moment. I actually created another index for text search. We'll again talk about that. And then I inserted two documents, one for John and one for Jane, inside the users collection. And then I also inserted two articles. I created two articles objects and then insert them in the articles collection. So this is basically what it does. It remove the users and articles collection if they exist, and then recreate them by inserting two documents in each collection. So knowing that, let's run this, and why it's not okay, so it's under shell scripts. Okay, blocks, it's in there. Let's say mongo load logs ps. Okay, so now they should be created, and let's head back to here and do a refresh. So now I have three collections under my database: articles collection, test one. Let me delete test one since we let me delete test since we no longer need it. And then the users collection, and very quickly. Let me see if I can make the fonts larger. Oh, cool. So Control plus will increase the fonts just like in a browser. So this is what article looks like. It has an ID, title, and text, which is the text of the article. And for author, I'm using the reference design, so it will have the author's ID here, referencing the user's collection. And it has a date, and it has also comments. So comments by itself is an array, and inside each comment object, a comment has a text, has an order, and this one I actually did embed design. I embedded the name, first name and last name of the author here. And I also have a tags, which is an array. The first article has 3 tags: NoSQL, MongoDB, and web development. And the second tag, second article has 3 tags: JavaScript, Node.js, and web development. Okay, so this is what my articles and users look like. Users are much simpler, just first name, last name, and email. Okay, so knowing what we know, let's do a few queries. The most important method for queries is the find method, and it takes two objects, or 2 documents if you want to call them. The first is a query object that specifies the query conditions, and the second one is a projection object that specify which properties we want to include in the result. If you remember, in SQL, we would say select and then a list of fields, and then from something, and from some tables. And this part is called the projection part. It projects on the results and select the columns we need. And same thing here. If you don't have any projection here, it will return the whole documents or the whole objects. If you specify some projection, it will return the properties you project. And so yeah, let's try a few basic queries. So start by listing all the users. So this is my query shell script, but I think I'll just copy and paste the queries instead of running this as a script. So how do we find all the users? We'll say DB, and then remember all the methods are collection methods. So we have to say DB and then the collection name. And then we say find. And we can give it an empty query object. And if we do that, it will return all the documents. Or we can simplify it by just saying find, and this will also give us all the documents. Now, what if we only want the first name? Well, remember, this is where we use projection. So here we can say DB users find, and we give it an empty object for the query object, and then we say first name is true, or first name is 1. And this is the projection object that basically says let's project on first name. And if we run this, it will give us only the first name. Notice that by default it will still give us the ID. If for whatever reason you do not want ID, you can simply say ID is false, and then this will remove the ID field and only give us first name. Okay, so this is how we do projection, which is pretty simple. But then if we have to specify some conditions, it gets a little bit cumbersome. So for example, let's say we want to find the users whose last name is Doe. Now, if you look at the documentation, which I highly recommend that you take at least a quick look, it explains how you do queries. And unlike SQL, which has a fairly straightforward query syntax, because MongoDB uses JavaScript methods to do queries, it has to come up with something somewhat weird looking. For example, if you want to specify a condition, you would need to say field and then operator and value as an object. So what that means is this one. What that means is if we want to say find the user whose last name is Doe, it will be something look like this. We'll say find, and then we'll say last name, that's the field, and then the condition is equal to Doe. So field name, operator, values. And you can see the operators here. You have equal, you have greater than or equal, in, less than, less equal, not equal, and so on. So this would give us all the users whose last name is Doe, which will be both users. The good news is that because equal condition is such a common condition, you can simplify this using a simplified syntax by simply saying users find last name is Doe. So if it's a equal condition, then you can simplify it by getting rid of the operator and just specify the value directly. So this would give us the same thing. So after this example, you can kind of see where we are going. So if you need to specify more complex conditions, the object syntax becomes more and more complex. So let's say we want to find the user whose first name is John and last name is Doe. And the way it looks is we'll have an AND operator, and the AND operator will take a number of conditions, and those number of conditions will be expressed in a list, in an array. And inside the array, then we'll have to say last name equals Doe, first name equals John. But fortunately, there's a shorthand form, so we can simply say first name is John, and then last name is Doe. Something like this. So this gives us John Doe, but not Jane Doe. Now, this is how we can use the AND operator. AND operator takes an array, and each array element is a condition, and when you specify a condition, remember either you can specify it as a full condition with field and then operator, or if it's a equal condition, then you can simply use the simplified syntax. So this is AND, and as you would probably guess, if we want to do a OR, it will be very similar, and that would be something like this. So just like AND, OR would take an array with a number of conditions, and the relationship between those conditions are OR. And what if we want to find users whose first name is John, or first name is Jane, and last name is Doe? Okay, so this one can be a bit tricky. So we will need a OR for sure, and this one will be first name is John, so this condition is okay, and then the OR is first name and Jane and last name is Doe. So we'll have to say and then something like this. Yeah, so Jane and Doe, something like this. It's a big OR condition plus an AND condition inside. And this would work? Yes, this works. Okay, so this one, you can simplify this by combining this AND into this. So we can simplify that AND by saying first name is Jane and last name is Doe. Yeah, actually we can also do this here for this one as well. So when it's an AND condition, you can combine those into one object instead of an array of objects. Yeah, so this would be the correct syntax. So this is basically how MongoDB query works. You can create a bunch of conditions by nesting various operators together, and if it's an equal condition and if it's a AND relationship, then there's a simplified syntax that lets you to write it in a simpler way. But otherwise, you'll have to write weird-looking query objects like this. So, what about arrays and subdocuments? Well, let's see. So, find the articles whose tag contains NoSQL. Remember, here we have our articles, and articles have tags, and tags is an array. So we want to find the ones that contains a tag NoSQL. This one looks like this. We'll say articles, find, and what's that? Okay, so the first one is field name, so we'll say tags, and then the operator is for, and the value will be NoSQL. Yeah. So what this one says is that we want to find all the articles whose text fields contain all of these elements. So all means it should contain all of the elements in the list. And this one will give us the first article using MongoDB, which contains NoSQL tags like this. There's again a simplified syntax. So instead of doing this, we can in fact simply do tags and NoSQL, and this would also work if I remember correctly. Did it work? Yes, it did work. So it find this one. So the full syntax is this: field, and then operator, and then value, and simplified syntax is this. And what about this one? If we want to find the articles John Doe has commented on, how do we do that? Well, let's see what the document looks like first. So comments are in an array, and inside the array there's an order field, and inside order field there's first name and then last name. So this one has a comment from Jane Doe, and this one has a comment from John Doe. So turns out that querying subdocuments like this is actually quite easy. So the query would look something like this. It will say article.find, and it will say comments. Is that, yeah, so that's a field name, and it will say dot order. That's a field name, and then it will say dot first name. So just like in Java expression language or many other types of expression languages, you can access a subdocument or a property using property.property.property. So this is specifying the first name field of the orders field of the comments field of the article. So this one will say should be John, and this one should be Doe, and that should do it. And if we run this query, oh, it doesn't do anything because I think I put the collection name wrong. Okay, so it finds the article called Programming Node.js, which has a comment from John Doe. Yes, so this is how we can query a subdocument, which is quite convenient. Just use the dot syntax to reach the fields or the property of the subdocuments. And then if you want to do join, there's no join like relational databases here. So MongoDB does provide something that's similar to join, but it's part of the so-called aggregation pipeline. And my guess is that it's not one query per se. It's probably multiple queries combined together, unlike in relational databases where it is one query. But regardless of how it is implemented behind the scene, this is a syntax. I'm not trying to do it live because I honestly cannot remember all those fields. But if you look at this, if you look at the query itself, it kind of makes sense in the sense that each field is pretty clear what it represents. So what this one does is we try to list the articles with their orders, and the reason being that for order field we only have a reference. The way to do a join-like operation is to use the aggregate method and the lookup operator. So what this one says is that let's get the articles and then also do a lookup from the users. Users, remember, is the other collection that has the orders information. And the local field is order ID, which is, of course, this field. And the foreign field is underscore ID of users. So you can see that this is basically just like in SQL, it's saying join articles with users where article.orderID equals to users._ID. And then it says put the result as an order property of articles. And if we run this, let me make sure I copied everything. Okay, I think I did copy everything. So now it gives us the two articles, and where are the others? I think they are not joining the others for some reason. Oh, other is here. Oh, okay. So originally it has an order field, and that field, I guess, becomes an empty array, and then the join result is here where we have the ID, first name, last name, and so on. So yeah, a bit weird looking, but this is how the result is looks like. And of course, if you want, you can do a projection after the join. So after the join, you project on the orders. So this will give us only the article orders. And actually, it's a bad example because it joins on the empty array rather than the other order field. What if we change this to order 2? Forgot about it. So, so this is how you do a join in MongoDB. Most of the time, you probably want to avoid this. Instead, using an embedded document instead. Not only it's probably less efficient, but there's a bit of tricky stuff going on, which I'm not sure if I saw this in previous versions. But anyway, so moving on, once you know how to do query, you know how to do update and delete, very similar to SQL. Just like in relational databases, if you want to do an update or remove, you have to specify first a query condition to select the ones that you want to update or remove, and then you specify the new values for the fields. Here are a couple of examples. I'm not going to do it live. So, for example, if you want to change John Doe's name to Tom Smith, you would call the update method, and then the query object will be first name John, last name Doe, and then the update object would be first name Tom, last name Smith, and that's it. And if you want to remove something, again, just say remove, and then specify the query object that select the articles to remove. Here are a couple of examples about changing array elements. If you want to add an element to an array, you use the push operator. If you want to remove elements from an array, you use the pull operator. Okay, that is about the query stuff for the most part, and then let's talk a little bit about indexing. So just like relational databases, indexing is important. Without index, performance suffer. To create index for documents in a collection is pretty simple. All you need to say is collection, and then create syntax, and then the fields you want to create index on. So for example, if you want to create an index on the last name, you would say create index last name, and then give it either a 1 or -1. 1 meaning you want to create the index in ascending order, and -1 is descending order. So in addition to default index, you can also specify some additional options for the index. For example, you can say this index is a unique index, ensuring that all the values in that property would be unique. You can also give this index a name instead of getting a default name. You can create index on array fields as well. And speaking of index, a very important type of index is called text index. And this allows us to do the so-called full text search. Full text search is a fairly big subject by itself, which we're not going to get into here. Basically, this is a technology that allows us to search words in documents in a very efficient way, and is the foundation for billion-dollar businesses of search engines. Many database solutions provide full text search capabilities. MongoDB has a little bit. It's not advanced, or it's not advanced, but it's there and it's free and it's easy to use. So that's good enough for our purpose. So, so what it looks like is this. First of all, in order to do text search, you have to create a text index. Each collection can only have one text index, but you can specify it on multiple fields. For example, here, the documents have two fields, name field and the description field. To create an index on both, you would say create index name and then text and then description text. So what we are doing here, we created our blog interface database, is that we created an index on the name field and the text field. So in other words, we have created I created the index on name. It should be called title. Okay, so that's not good. It should be title. But anyway, at least we have the second one, right? And this one is text. So once you have that index, then you can search keywords in both title and the text, something like this, using the text or query operator. So let's say I want to search for articles that mention MongoDB. So we should find this one because at least the text field is indexed. So we'll say db articles find, and the operator is text, and the value is search for MongoDB. Okay, so it did find this one. And this is how we can create a text index and do a text search. As I said, the text search capability in MongoDB is pretty primitive. You can search it, and that's pretty much it. But still, it's quite useful because it's such a common operation. Okay, so that's about it for query, update, and text search stuff. And let's quickly look at how we can use MongoDB in Node.js applications. The driver we need, or the library we need to connect to MongoDB from Node.js is the MongoDB Node.js driver, of course, and the package is called MongoDB simply. And I have some code here, and this I already included MongoDB package, and so head over to the documentation. You can find some examples and API documentation and so on here. The important thing is the API documentation. And to understand the API, you can see that there are lots of okay, I'll just call them classes. There are lots of classes in this API, but you don't really need to know all of them, at least not all of them all at the beginning. Here are the 4 things that you need to know. Client, DB, collection, and cursor. So client is how you connect to a database. And then once you connect to the server, you specify database. And once you get a database, you specify a collection. And once you have the collection, you can basically run those collection methods to search, to update, to remove, and so on. So that's the process. Another important thing to understand is the connection string format, or this one. So in order to connect to a MongoDB database, you need to specify a connection string, which starts with the MongoDB protocol, and then optionally username password, and then the host name, and optionally the port number, and optionally the default authentication database and other options. So knowing all that, this is what you would do to connect to a MongoDB database and then do something. So the first thing you do is you require the package and get the Mongo client out of the package. And then you would say Mongo client connect and give it a database URL. So I have constructed the database URL here, which has a MongoDB protocol, username, password, host and port, and also the default authentication database, which is the same as the database username. And you need to provide the database URL, and then another option. If you don't have this option, it will give you a warning. And then a callback function. So just like any Node.js callback function is error first. So the second one is what you want, and this is the result of the client connect method, and it gives you a client. And the client, you'll call the DB method on client, it will give you the database. This is one of the few methods that do not require a callback. It will just return a DB object. And once you have the DB object, you'll need to get hold of a collection. And here, once again, it has a callback, and this is a collection, and then you do the insert stuff. So I have a couple of users here. I'm inserting into the users collection. So once you are done, you close. The close has its own callback, and so on and so forth. So as you can see, if you use the callback style asynchronous programming, if you want to do a few things sequentially, very soon the callback stack becomes very hard to manage. Fortunately, the MongoDB driver is designed in a way that most methods will return promise if no callback function is provided. This is actually similar to the, I think, bcrypt JS package we used last time. And this is a great feature because this allows us to use promise, which is a lot easier to use than callback in my opinion. So very quickly, if we want to do the same thing here using promise, this is what it looks like. So I still have the first part are the same. So we still need to require the MongoDB driver. I still have the two user objects, and I still need to create a DB URL. But the rest looks quite a bit easier. So the first thing we'll do is we'll create an async function, and it doesn't really matter what is called. I'll call it async function. Just call it one. And inside we'll do the MongoDB connect thing. So notice that here we provide a callback function, and here we don't. And so connect will return a promise, and we await on the promise, and this will give us a client. And then the client will give us a DB. As I said, getting the database is one of the few methods that just return an object instead of requiring a callback or promise. So, and then we can get the collection. And this time again, we'll wait on this so that this one does not have a callback. It will return a promise, and we await on the promise to get the collection. And then we do insert many. We'll do insert many users, and we'll await on this as well. And last but not least, we'll await client close. something like this. Okay. So now if you compare this code to this code, you can see that this one is a lot easier to read. Okay. And then we can just run this code. Okay, so if I actually run that, I'll say test3 promise, and that should insert a couple of new users into my users collection, and indeed it did. So these two are the two new ones, and these two are the old ones. So this is how you can use the MongoDB driver to connect to a MongoDB database using from a Node.js application. All in all, it's pretty straightforward once you get used to using promise and also getting used to the collection methods, insert, remove, find, and so on. Okay, so a couple of things about the MongoDB driver and the code. First of all, there's a difference between Node.js code and MongoDB Shell scripts, even though they all look kind of like JavaScript. Notice that this is MongoDB Shell scripts and this is Node.js code. Those are two different things. This code is interpreted by the Mongo Shell JavaScript interpreter, and this is Node.js. So you can use all the late Node.js JavaScript features, but here just the basic methods from MongoDB Shell. And secondly, Mongo client actually has its own connection pool. So what that means is you would want to use the same client / database / collection as much as possible before closing it. You don't want to use it once, close it, and then connect again, and then run another query. That would be very inefficient. Just run all your queries using the same client. And of course, MongoDB also supports many other languages. You can find out the drivers or the connector libraries for all kinds of other languages. And before we conclude, I want to say a few things about NoSQL databases versus relational databases. NoSQL databases are designed to be easier to scale, so-called horizontally, meaning that you add more servers to it. And also, document databases make data modeling easier and data access more efficient for certain applications, like what we just saw. If you use MongoDB for a blog application, for example, you can embed user information and comments inside the same article object so that it only takes one database access to retrieve all that in order to display an article. And that's quite efficient. And also, using only one language, JavaScript, for everything is quite appealing if you are familiar with JavaScript. With that being said, do understand why relational databases are so widely used and will continue to be widely used, because it does have lots of benefits of its own. In particular, relational databases support the so-called ACID properties for transactions. If you don't remember what ACID properties are, please do look it up, because this is a fairly common interview question. If you say you know database, an interviewer may ask you, then tell me what ACIDs are, and you'll have to say, A stands for atomicity, and C stands for consistency, I is isolation, D is durability, and explain what those things are. And also, relational database give us the standard query language SQL, which is not only quite easy to use, but also very importantly standardized across different systems. And after writing some queries using JavaScript or for MongoDB, I think you would appreciate SQL more. And not to mention that the reliability of relational databases that has been used and proven in the last several decades. So if you move away from relational databases, do understand what you gain and what you lose. And also don't get the idea that relational databases are only for small data sets. They are for very large data sets, except that maybe not the Google Facebook type of scale, but still, big banks, big organizations all use relational databases. They do handle very, very large data sets, and their scalability and performance have continued to improve, especially with cloud technologies. And the most important thing, I guess, is to understand your application requirements and your data modeling needs and see which one fits better with NoSQL or relational ones. Here, I think, is a pretty good well, it's not exactly a guide, but it's kind of a general guideline for different type of databases. So this is a page provided by Amazon. As you know, Amazon Cloud provides many different database services. Some of those are relational, some of those are document, some of those are key value, and so on. So all of these are database services provided by Amazon Cloud. And this is the recommendations made by Amazon, basically saying that if you are doing traditional applications, ERP, CRM, e-commerce type of applications, you'll probably want to use relational database, and Amazon provides several of those. If you do content management or catalogs or user profiles, then you may want to use document database, and Amazon provides one that's compatible with MongoDB. And if you do fraud detection, social networking recommendation, you'll probably want to use a graph database, where Amazon provides one, of course. So bottom line is that understand what application you build, what requirements are, and find the right fit in terms of databases. So that concludes our discussion about MongoDB. So here are the links for MongoDB menu, and in particular, please check out the data modeling section regarding some general guidelines about how to create data models for MongoDB, and the documentation for Node.js driver. Okay, so this is it for this video. See you in the next one.